Hello, good morning everyone. Welcome back to our new norm teaching. How's your day? Okay, excellent. Now, before we proceed to our next topic, I would like you to analyze the prayer. Okay, so in the name of the Father, the Son, and the Holy Spirit. Amen. Okay, good morning once again. So now, Class Mayor will be checking your attendance. Okay, before we go on, I would like you to answer these following here. The one is differentiate the following function, and the second, solve first equation, then state the operation process using each column. And who can get the right answer, I will give him a prize. Okay, so I give you 5 minutes to start. Okay. Alright, so first, everyone is done. Okay, so first, I will show you the answer and compare it to your word if it is correct. Okay, so this is the answer of the first. The 1, 2, and 3. Okay, so for the second will be will be this one, and you can get a correct answer, then I give you a prize, right? So who's got a perfect score? Alright, so later I will give you your prize. So we can proceed to our next lesson. But by the way, what did you notice in the solution of column A and column B in each number? Okay, it has the same given number, right? And what about the difference between the two columns? The difference of the two columns. Alright, it is the operation or process that we use. Okay, how is column A related to column B? Alright, so column B is the inverse of column A. Alright, so inverse or the inverse operation is the operation that reverses the effect of another operation. Okay, for example, addition and subtraction are inverse operation. Okay, start with 5x squared, then add the 6x squared, we get the 11x squared. Now subtract it to 6x squared, and we get back to 5x squared. Did you see it? Okay, so another example. Multiplication and division are inverse operation. Here, start with 4x squared. Multiply by 3x cubed. We get this 12x squared. Now, divide by the 3x cubed, and we get back to the 4x squared. Okay, so did you get me? Okay, so after we discussed last meeting the derivatives of a trigonometric function, now we are going to talk about its inverse operation, the antiderivatives of trigonometric function. Okay, so this is our objectives for the day. Alright, so at the end of the lesson, the student should be able to define antiderivatives. Second, state the common antiderivatives trigonometric function. And the third one, apply the given and antiderivatives rules to integrate. Okay, so who can define the 6 trigonometric function? Okay, so The 6 trigonometric functions are the sine, cosine, tangent, cosecant, secant, and cotangent. Very good. Okay, now let us recall the derivation rule before we proceed to anti-derivation rule. Okay, so we have the derivative rule here. We can recite our derivative rule. Okay, so d is over to dx in x is equal to, what is that? Okay, cos x, right? The number 2 will have a sin x. And the 3 sec, and the 4 cos. Of course we have this x and cosec scotan. Okay, and these are our derivative rules. Okay, so how did we get our answer? Alright, based on definition of antiderivatives, we simply reverse the rule and putting the integral sign and we add constant. Okay, so based on our activity and discussion earlier, let us now define the antiderivatives. Alright, okay, here. So let's read. Antiderivatives are the inverse operation. Okay, I will write this space here. Okay, so antiderivatives are the inverse operation. Okay. Of differentiation, the symbol will be okay. Alright. Indicates the operation of anti-differentiation of fx. Okay, which is called the what? Okay, integrand. Integrand. Alright. The function being anti-differentiated or integrated. Okay. So now I would like you to get 1/2 and compute the following using the antiderivative rule. I'm going to give you 5 minutes to answer that. And then we will check out your answers. Okay. Alright, so you are done now. Let's check your answer. Okay, for number 1, we have the this is the property of integrals, right? Second, next, to dx. 4 sec. Also properties of integrals. Okay, so we have because x is 4 tan x plus c. So this is from the table. Alright. Okay, so for number 2, we have equals 2x minus 6 dx. Are you following me? Okay, so c equals, since one of the, alright, so this using the what they say? Okay, substitution. Alright, so here the properties of integrals and so on. Okay. Now this is from the table. Okay. Table. Alright, so we have the y. Sin. See, okay. Now we're using the substitution. Okay. So okay. Did you get me? Alright, so now I would like you to calculate the following integrals. I will give it to you. Also, this is a 1/2 crosswise. Okay, so this is, you're going to calculate. This is the following integrals 1 up to 10. Alright. Since we are running out of time, so you can pass it tomorrow. Bring it to your home and it will be your assignment for today. So goodbye everyone.